In this video, I'm going to go through how to solve a linear programming problem in the MyMathLab. So it's also about just getting it on the graph in MyMathLab. So here we're given the objective function and then 3 different constraints. So the constraints are what we're going to put on the graph, and then we're going to use those constraints to determine things about the objective function. So starting with the first constraint, these are constraints on x. This is saying x is greater than or equal to 0 and x is greater than or equal to 0 and x is less than or equal to 7. So those are actually 2 different boundaries squeezed together in one. So we're going to start, I like to expand this grid just a little bit by clicking on the magnifying glass. So we'll do the x greater than or equal to 0 first. So that means that we're not going to go below our y-axis. So we'll select the line tool down here and just click on 2 places on the y-axis, and this keeps x bigger than 0 because x goes negative when we go to the left of the y-axis. Okay, and then we'll do x is less than or equal to 7. So we'll click on the line tool again and we'll go to 7 on the x-axis and we'll draw in a vertical line for x at 7. Okay, and we're doing a solid line, not a dotted line, because of the equal bars on the inequalities. Alright, so those are the constraints on x's. Next we have the constraints on y. Y has to be bigger than or equal to 0, so we'll click on our line tool again, and then we're going to go along the x-axis for this, because anything below the x-axis would be less than 0 for the y. So the y boundaries use horizontal lines because they're creating vertical boundaries. And then the other constraint with y is that y has to be less than or equal to 8. So the y of 8 is here. So we're going to click on our line tool and draw in a horizontal line for that y value of 8. So that basically just creates this box here. So then the third constraint is an equation that has both x and y's in it. To graph that, what I'm going to do is put it in slope-intercept form and then use the slope and y-intercept to graph it. To put that in slope-intercept form, all we would need to do is subtract the x from both sides of the inequality. That would give us y is greater than or equal to a negative x plus 6. So that means that our y-intercept is at 6. So with the y-intercept at 6, I'm going to select my line tool and put a point at 6. And then again, once I put that in slope-intercept form, that's y is greater than or equal to a negative x plus 6. That means the slope is a negative 1. So since it's a negative 1, I'm going to go down 1 and I'm going to go right 1. And I can put another point. And then that's that line there. So that sets the line. Now I need to decide what region to shade in. So I need to come over here and select the fill tool, and the question is which one of these regions am I filling in? Now when I solved this last inequality here for y to put it in slope-intercept form, it was y is greater than or equal to negative x plus 6. So y is greater than or equal to this line. So the y values are greater than this line when we're above it. So I'm going to shade the boxed in region that is above that line, but inside of all the other 4 lines that I put. So that shades this region here. So again, when I solved this, it was still greater than or equal to, because I didn't divide by a negative or anything. And so that means I need to shade above the y value of this. This gives my y values, and so they're greater than when I'm above that line, so I filled in there. Alright, we'll check our answer on that. Yay, excellent. All right, now we'll go to the next phase. What they're going to want is the values of the objective function at each corner of the graphed region. So that's this corner, this corner, this corner, this corner, this corner. And you can just pick one and go clockwise or counterclockwise, it doesn't matter. But what you're going to do is once you pick a corner, that gives an x and a y value. So this corner right here has an x value of 0 and a y value of 6. And you're going to take those x and y values and plug them into the constraint function. So an x value of 0 would zero this out. A y value of -6 would give us a -24. Okay, now I'm just going to go on to the next corner going clockwise. So this would be this corner, and it's going to be the order pair 0, 8. So an x of 0 would zero out this x term, and then a y of 8 would give me a -32. So I'll just go down here and add it to my list, comma. Moving on to the next corner, this corner here is an order pair that's 7 for my x and 8 for my y. So plugging that in, 7 for my x is 21, and 32 for my y is, 8 for my y is 32. Sometimes I give the answer away there. And then 21 minus the 32 is going to give me a -11. So we'll add that to our list, comma. Move on to the next corner. The next corner is the order pair for my y value. Now that's a 0 and my x value is a 7. So a y value of 0 zeroes out my y term, and then an x value of 7 would give me a 21. So I'm going to put that in my list. 21, comma. And then going on to the next corner, I'm here. This still has a y value of 0. So it's the order pair 6, 0. That's going to zero out my y term, but give me an 18 for the x. 18, comma. And that's all of my corners. I've made it all the way around now. So we'll go ahead and check the answer on that. Fantastic. So then the next part of the CAT question asks us, where is the maximum value of z? Now z is our objective function, okay? So, and we were coming up with z values in this list. So this is just asking you what is the biggest number in this list. And so that's 21. Yay! The next question asks, what's the maximum value occurs at which point? So this is my maximum value. Now they're asking us which point on the graph generated that value. So when did we get the 21? And so that was at this point here. If you remember when we plugged in the 0 for the y and the 7 for the x, that's what gave us the 21. So we want to put in that order pair, and that's going to be the order pair 7, 0. Remember when you're doing this, that the x value always goes first. So that's the order pair 7, 0, and nice work. So that's it. That's the full problem there. Just getting all the lines graphed, then getting the maximum, not the maximum values, but all the values for all of your corners. Then you choose which one's the biggest, and then you state the order pair that produced that maximum value. If you have any questions about this, or if I can help you with anything else, please let me know.